Okay, so hi. In this video, we will talk about derivatives and specifically derivatives as a function. You might have come across something of the sort. F into A is equal to limit of h as h tends toward 0 of a function A plus h over h. So typically this can be referred to as the first principles of finding derivatives, or you could also say that derivative as a function. So we will go straight to doing some examples, and the examples that I kind of want to use in here, I'll start off with a somewhat simple example, which is if f into x, if f of x is equal to x cubed minus x, what is f prime of x? So in this question, really what they're looking for is for us to find the derivative of the function f into x. So in normal terms, typically, if you just go by, quick derivative, we typically just say that f of x is literally, you drop the 3 down, x squared minus 1. And for those of you who are new to mathematics, or rather calculus, derivatives, which could be written as f into x, the same thing as df dx, meaning derivative of the function, is equal to, and so in this case you take the power. If you had, for instance, I'm going to use a somewhat different function and I'll write it to the side here. So for instance, if you had m to the power n, right? Derivative of this number, so derivative of dm with respect to n is given by m to the power n minus 1 times that n. So that's how you find the derivative. So in this particular case, this is how we find that, because if you take 3 and you drop it down, it will be there, which is that, and n minus 1, which becomes 3 minus 1, which is that, and then minus 1, derivative of any variable or any derivative of a variable, say x, is equal to 1. Derivative of a constant is equal to 0. So that's how you go about it. But that's the quick derivative, which is the kind of derivative you will do on a daily basis for the most part. It's rare, except in your exam, that you'll find somebody asking you to do this in first principles using limits. I'm also assuming that you've taken a class, you've learned maybe a topic about limits and do understand how to apply them. So if you do have questions about how limits are found, how you do limits, and in general, you can post that in the comments and I can make a quick video about it. But let's go to first principles. So we know this is going to be our final answer from a quick derivative standpoint. But if we go to the long way, for a function f of x, the derivative f into x, right, is given by limit of that function at the variable x plus a small change in x minus the original function f into x over a small change in x. Now this small change in the variable is what they typically represent as h. So going back to that expression that we have earlier. So in our case, if we have x cubed, so in our case we have f into x is equal to x cubed minus x. We're just going to go ahead and say that the derivative of that function is given by, sorry, here I forgot to add limit. So as change in x tends to 0. So in this case, we'll say limit of the function f into, in this particular case, x plus h cubed, right, minus x plus h, right, minus the original function, which is x cubed minus x over h as h tends to 0. Now all we gotta do in this particular case now is open up this function, and once we open up that function, in other words we expand it out, we can be in position to weed out what we want to weed out and leave in what we want to leave in. So I'll go ahead and open it up. So this is equal to limit as h tends to 0 is equal to x cubed is equal to x cubed plus, when you open this expression up, this is what you get, plus 3 x squared h plus 3 x h squared plus h cubed, now minus this part right here, so minus x minus h, now minus this part right here, so minus x cubed plus x over h. And what this one gives us is x cubed is going to cancel out with x cubed because it's minus, and then you're going to have what else here can cancel out? What can we see? We see plus x and minus x, they also cancel out. And then we see, a lot of h here, which can cancel out. So this h, one h there, one h there, one h there will cancel out with that, leaving us with an expression that is 3x squared from this part, plus 3xh plus h squared, right? But you still have your limit, so limit as h tends to 0. So if I go ahead and substitute in here for 0, or for a number that is very, very close to 0, and a number that is very, very close to 0, I would get this is equal to, what do I get? Actually, I missed out something here. There is a 1 here, right? Because that h, this h, and that h cancelled, but a 1 remains there. So this is minus 1. So here you'd get something that results into 3x squared. This goes to 0, that goes to 0, minus 1. as your final answer. So, which is equivalent to what we got earlier by just going the direct route. Thank you.